Hey students, I want to go over an example of how to fill up a dihybrid in Punnett square. These instructions are on the dihybrid crosses notes on the class notebook. So these are the steps on how to fill a dihybrid cross. We're going to go over all of those steps. I want you to note that step number 4 is a little different. What they're doing with step number 4 is they're getting the different combinations of gametes of a 4-letter code. Okay, so with a dihybrid cross, we're focusing on 2 traits at the same time. That's why you have 2 different kinds of letters. In this case, we have an R and a Y. The R codes for one trait and the Y codes for a different trait. So what you're doing on number 4 is you're getting the different combinations of RY, and that's going to be the gametes that the parents can contribute to their offspring. Okay, and I'll explain when I show you. But what you end up getting is kind of like the FOIL method in mathematics, where you combine the first letter and the third letter. Okay, so you have like capital R, capital Y. Or you can combine the first letter with the last letter. You can have capital R, lowercase y. Or you can combine the second letter with the third letter, lowercase r, capital Y. Or you can combine the second letter with the fourth letter, which would be like lowercase r, lowercase y. Okay, so this is important in dihybrid crosses. Let me show you what I mean by that. Okay, so here's the example. In pea plants, round seeds, capital R, are dominant to wrinkle seeds, and yellow seeds, capital Y, are dominant to green seeds. Create a Punnett square that shows the cross between 2 pea plants that are heterozygous for both round and yellow seeds. So you want to start off by making a 4x4 grid. I do squares about an inch big, and you want to have 16 of them. Okay, so what I do, I count a box of 16 by 16 in my graph paper. And once I have my outside box, I separate that into 4 columns. So here's column 1, 2, 3, 4. And then I separate that box into 4 rows. So you're going to end up with a 16 grid box. Okay. Now, the first thing is you want to do, you want to write what your alleles represent. So we have the letter capital R, and the capital R, it tells us in the problem, it codes for yellow, it codes for a round body, okay? And then I write the lowercase r, so the lowercase r codes for a wrinkled seed. The capital R codes for a round seed. And the the uppercase y codes for yellow, and the lowercase y codes for green. I got that directly off the problem. Okay, so once I determine that, you then want to visualize the parents. So the problem tells me that both parents are yellow and they have brown seeds. So I write that on the outside of the box like this. So here's parent 1 and here's parent 2. Now, the next thing you want to do is you want to find what's the code that codes for a round yellow seed. So if we look at round is coded by a capital R, which means that if it's heterozygous round, one is going to be capital and the other one's going to be lowercase r. Okay. And they also have a yellow seed. So we look at the yellow, and that's coded by a capital Y. And if it's heterozygous yellow, That means that one is capital and one is lower, okay? If it says homozygous, then both are lower or both are capital. Anyway, once you do that, you're going to write the parent genotype. So we determined it was heterozygous for both traits. That's why we end up with capital R, lowercase r, capital Y, lowercase y. And the second parent is also round and yellow, and it's also heterozygous for both traits. So it's going to be the same. Excuse me. So this is where we get to number 4 now. Number 4, what I was talking about earlier, factoring out the different combinations of RY. Because those are the gametes that are going to get passed on to the children. So I look at my first parent over here on the left, and I can have first letter and third letter, which is capital R, capital Y. Or I can have first letter and fourth letter, capital R, lowercase y. Or I can have lowercase r, capital Y. And the next one, I could also have lowercase r, lowercase y. So that's the different gamete combinations for parent 1. And then you do the same for parent 2, which is going to be the same because we have the same genotype. Okay. So once you have the 4 different gamete combinations, those are the letters that go outside of your box right here. So for parent 1, we write capital R, capital Y, and so forth. Okay, these gamete combinations. And for parent 2, we do these ones on the left, and they go up here on the top. Okay, so you fill it in. Now, the next step is to go to start filling in the genotypes or the phenotypes for each. So each parent is going to donate 1 R and 1 Y, which means that the child will have 2 R's and 2 Y's. Okay, I'm going to stop sharing on the screen right now and go to the document camera so you guys can see what is happening there. Documents. Oh, here it is. Here's the document camera. Okay, so here's what I have. Parent 1 donates a capital R, and capital Y, capital Y. So as long as it has one capital R, it's going to be a round seed. This one is. And as long as it has one capital Y, it's going to be a yellow seed. So this one is yellow. Okay, then we do the next box. Capital R, capital Y, lowercase y. So as long as we have one capital R, it's round. And as long as we have one capital Y, it's yellow. So we continue. Okay, so far we only have brown yellow seeds. Now on the next row, same thing. This one is capital R, lowercase y, uppercase y. As long as we have one capital R, it's round. And as long as we have one capital Y, it's yellow. Okay, so this is round and yellow. And the next one, capital R, As long as we have one capital R, it's round. But this seed is not yellow. This seed is green because we have both lowercase recessive alleles that code for a green seed. Okay, so this is a green seed. And then we do the next one. So again, we go back to being brown and yellow. And then we do the next one. Oh, this is a lowercase r. Okay, so we have capital R, lowercase r, lowercase y. This is also round because we have at least one capital R, but this time it's green because we have two lowercase y's. Okay, so we keep on going. Next row, lower, upper R, upper Y. And this is round and yellow. And the next one, lower, upper, lower. And this is round and yellow. And the next one, we have lower R, upper Y, upper Y. Now, this seed is different because this is no longer a round seed. It's wrinkled because we have the two recessive R's. So instead of being a round seed, I'm going to draw a wrinkled seed. But it's still yellow because it has at least one capital Y. So we do the same thing on the other one. This time, the Y is dominant and the other Y is recessive, okay? So it's also a wrinkly seed and it's also yellow. Okay, so on the next row, we have lower R, lower Y, upper Y. And this is round and yellow. And the next one, we have lower R, lower Y, lower Y. So this is not, well, this is round because it has at least one capital R, but it's not yellow. This is a green seed because we have both recessive traits. And then over here we have little r, little y, big Y. So this is a wrinkly seed. Wait. Yeah. It's a wrinkly seed, but it's yellow. Okay. And then finally, we have little r, and little y. So this seed is little r, wrinkled, and little y, green. Okay. So that's how you fill it up. And then finally, you go over the phenotypes and genotypes. So I'm going to go back to the PowerPoint and explain how that works. So when you have all your phenotypes, you count them. So you count whatever you got more of. I have more round and yellow seeds. You count them, it's 9 out of 16. And then I have round and green. So it's 3, 1, 2, 3 out of 16. And then I have yellow wrinkled seeds. So I count those 1, 2, 3 out of 16. And then I have one wrinkled green seed. That's 1 out of 16. So that's how you get your percentages. And if you're writing your ratio, you would write it from more to less, 9 to 3 to 3 to 1. So for every 9 yellow, I have 3 green. For every, oh, I'm sorry, for every 9 round, I have 3 wrinkled. And for every 3 yellow, I have 1 green. Okay, so those are your ratios. And that's it. That's how you fill up your dihybrid cross. I hope this helped. You have example number 2 on the notes and also the summary that you can work on by yourself. Okay. I hope this video helped you.